As we move into the second module of our first unit of study, we're going to take a look at the atom. Figure we should start at the beginning, right? So the atom is the smallest particle of matter that retains the properties of the substance. Remember, we've talked about an element. An element is a substance that cannot be broken down into two or more simpler substances by any means, chemical or physical. Okay? So our understanding of the atom has actually developed over a really, really long time. It originally was conceptualized in about 400 BC by a Greek philosopher named Democritus, who coined the term atomos, which is the Greek word for indivisible or indivisible. And so he was the first person to think that there might be something smaller that we can't see in matter. And then you fast forward about 2,000 years, and we get to John Dalton and this list of distinguished scientists here. This is by no means all of the scientists who are involved in our understanding of the atom, but these are the high points. Okay, so you need to look up, you can look up in the textbook, you can look it up online, but you need to know these people and what they did to contribute to our understanding of the atom. Okay, but we're going to go ahead and jump into the results of their work. So by the time we get to James Chadwick here at the end, this is 1932 at that point, we had discovered all of these subatomic particles. The prefix sub means smaller or less than. So these are less than atoms. These are the particles inside the atom. There's three basic particles. We have protons, neutrons, and electrons. And so this table just kind of gives us a comparison of the three. If you notice, the protons and neutrons are inside the nucleus, while the electron is found outside of the nucleus in what's called the electron cloud. You don't need to know these mass values, but just take a look at proton and neutron. They're both on the order of 1.67 times 10 to the negative 27th kilograms. So they're almost identical mass. And they are 4 orders of magnitude larger than the electron. So they're about 10,000 times the mass of the electron. Putting that into terms of something called the atomic mass unit, which just converts it into a more usable number. If you notice, protons and neutrons are right at 1 atomic mass unit, and electrons are 0.0005. Okay. As far as the charge of the particles go, protons are positive, neutrons are neutral, and electrons are negative. So since matter is charge neutral, that means that it must contain an equal number of protons and electrons. So when we have a neutral atom, it has equal protons and electrons. So it turns out that we can get a lot of information from the periodic table about atoms. The atomic number, which I'm just going to kind of draw a box over here for one of our periodic table elements. We'll do carbon. Okay, so this number at the top, this 6, that is the atomic number. And we have the atomic number signified with a Z. Okay, that's the identity of the element. So the atomic number for carbon is always 6. Carbon always has 6 protons. If an atom has more or less protons, it is not carbon. Okay, so that can't change. But the mass number, which has the symbol A, since protons and neutrons make up most of the mass number is equal to protons plus neutrons. Now it's very, very important to notice this number here at the bottom, the 12.011. That's the atomic mass. That's not the same thing as mass number. We'll talk more about it a little bit later in this module. But for right now, mass number is a whole number. It is number of protons plus number of neutrons. So we cannot have a decimal involved in it. And atoms that have the same number of protons but different numbers of neutrons, so it's the same element, but it has different mass numbers. Those are called isotopes, okay? So isotopes, protons are same, differ in the number of neutrons. So that means they're going to have a different mass number. And so it turns out that most elements, not all, but most elements exist as at least two isotopes in nature. Some of them exist as more than that. Okay, some of them have 20 isotopes. So to know more about how the element's made up, we need to know something about the percent or natural abundance. So in other words, how much of the element is made up of that isotope. And we'll talk more about that a little later too. So when we want to write isotopes, one way of doing it is by writing the name of the element with a dash and its mass number. So carbon 12. This is a carbon atom with a mass number of 12. We can also write it with the chemical symbol in the format mass number over atomic number, element symbol. So for carbon 12, it would be 12, 6, carbon. Sometimes you'll see it written just 12 carbon because that atomic number you can always get from the periodic table. You just go look up carbon. Okay. An isotope of carbon is carbon 14. That's what's used for radioactive carbon dating. And so its isotope symbol would be 14C. And again, there's a 6 there that's understood because it's carbon. Okay. So to get the protons and neutrons, well, the atomic number is the number of protons. And then the neutrons are going to be mass number minus atomic number. So we subtract the mass number minus the atomic number. So in this case, 12 minus 6 is 6. For carbon 14, it still has 6 protons because it's still carbon. But its neutrons are going to be 14 minus 6, or 8. So it has 2 more neutrons. So let's take a look at a couple more examples here. We have potassium 39. Okay. So potassium 39, if we go to the periodic table, and yeah, here we go. Right here's potassium. Its atomic number is 19. So it has 19 protons. And then to get the neutrons, we just do mass number minus protons. So 39 minus 19 is 20. Pause the video and try chromium 52. Okay, hopefully you did that. Go to the periodic table, find chromium, it's number 24. So it has 24 protons. And then 52 minus 24 is 28 neutrons. So in the next video, we'll talk about one more form of atoms called an ion, and then we'll move into some more information about the periodic table. Thanks for listening.